4 billion miles from where you're sitting right now, there's a world small enough to fit inside the continental United States twice over, and it appears to be running its own private cooling system powered by nothing more than a thin veil of haze hanging in its sky. No one built it, no one expected it, and until very recently, no one had the instrument sensitive enough to even detect that it was happening. This is the story of what scientists have now confirmed about Pluto, and why a world we spent decades dismissing as a frozen afterthought is turning out to be one of the strangest, most chemically active places in the entire solar system. Stay with me, because by the end of this, you'll understand why researchers are now comparing this tiny, distant world to the icy moons we usually reserve for questions about life itself. Before we get into what Pluto is doing to its own atmosphere, it helps to understand how little we actually knew about this place for most of the last century, and how strange its story has always been. The search for Pluto began not with Pluto itself, but with a mistake. Astronomers in the early 1900s believed something massive was tugging on the orbits of Neptune and Uranus, some unseen planetary body pulling at them from the darkness beyond. That belief sent a 24-year-old lab assistant named Clyde Tombaugh, working at an observatory just outside Flagstaff, Arizona, into one of the most mind-numbing jobs imaginable. Night after night, he photographed the same patch of sky, then compared the plates side by side, hunting for a single point of light that had shifted position against the fixed backdrop of stars. Most nights, nothing. Then, in February of 1930, something did move. A faint dot had crept just slightly out of place, and that dot turned out to be Pluto. For most of the following century, it carried the title of the 9th planet in our solar system, even though nobody had the faintest idea what it actually looked like. Then, in 2006, the International Astronomical Union held a vote and reclassified it as a dwarf planet, quietly demoting the only world in recorded history to be discovered, celebrated, taught in classrooms for generations, and then formally voted out of the category that had defined it. For a lot of people, that felt like the end of Pluto's story: small, distant, unimportant, easy to file away. That assumption did not survive contact with actual evidence. And it's worth appreciating just how much of what people believed about Pluto for most of the 20th century was built on guesswork. Telescopes on Earth could barely resolve it as anything more than a blurry smear of light. Its orbit could be tracked with reasonable precision, but its size, its surface, whether it even had an atmosphere at all, remained genuinely open questions for decades. Some early estimates wildly inflated its size based on gravitational effects on Neptune and Uranus that later turned out to be measurement errors rather than anything Pluto was actually doing. In other words, the public picture of Pluto was, for generations, guesswork built on top of more guesswork. That makes what happened in July of 2015 even more remarkable. After a 9.5-year journey across billions of miles of empty space, NASA's New Horizons spacecraft screamed past Pluto at more than 30,000 miles an hour. It had exactly one shot. No orbit, no second pass. Just a handful of minutes to gather everything it possibly could before continuing on into the darkness of the Kuiper Belt forever. What it sent back rewired everything scientists thought they understood. A massive, pale, heart-shaped plain stretched across the surface, strangely smooth and young-looking next to the ancient battered terrain around it. Mountains of solid water ice rose more than 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like bedrock. Fields of nitrogen ice appeared to be slowly churning in giant convection cells, hinting at motion and heat beneath a crust everyone had assumed was geologically dead. And layer upon layer of blue haze rose hundreds of miles above the surface, glowing faintly even when backlit by the distant sun. Pluto did not look like a leftover chunk of frozen rock. It looked like a world still in the process of becoming something, but New Horizons only got one look. Whatever it missed in that brief flyby would remain a mystery for years, because what researchers really needed wasn't a better photograph. They needed a way to read Pluto's chemistry directly, from millions of miles away, without ever launching another spacecraft. That's exactly what the James Webb Space Telescope eventually made possible. Here's what makes Webb fundamentally different from something like New Horizons. It doesn't fly past anything and take a snapshot. It reads light itself, breaking it apart into individual wavelengths to reveal the precise chemical fingerprint of whatever it's staring at. Pointed at a faint pinprick of reflected sunlight billions of miles away, Webb can determine which molecules are present, how warm different atmospheric layers actually are, and how all of it changes over time, without physically traveling anywhere. The technical hurdle here deserves some credit of its own. From Webb's point of view, Pluto and its large moon Charon sit so close together in the sky that separating their individual heat signatures was nearly impossible for earlier telescopes. Researchers had tried repeatedly, before Webb ever launched, to detect the exact signal we're about to discuss, and repeatedly came up empty. Not because it wasn't there, but because older instruments simply couldn't tell how much of the detected warmth belonged to Pluto and how much was bleeding in from Charon sitting right next door. Webb's much larger mirror and far more sensitive infrared instruments finally cracked that problem, allowing scientists, starting in 2022, to cleanly isolate Pluto's own thermal signature for the first time in history. What's come back since hasn't just been prettier pictures, it's been closer to a full diagnostic readout of a world behaving in ways researchers are still working to fully explain. The first major finding involves that same blue haze New Horizons photographed back in 2015. Scientists already knew Pluto's thin atmosphere was wrapped in a delicate shroud of hydrocarbon particles. What nobody had confirmed was what that haze was actually doing to the world underneath it. Back in 2017, planetary scientist Shi Zhang at the University of California, Santa Cruz proposed something that sounded almost backwards. On Saturn's giant moon Titan, atmospheric haze traps heat and warms the surface below, the same way a greenhouse works. Zhang argued that Pluto's haze might be doing the exact opposite, soaking up sunlight during the day and then radiating that energy straight back out into space as infrared heat, faster than Pluto's razor-thin atmosphere could ever hold on to it. In effect, the haze wasn't acting like a blanket, it was acting like a radiator, actively bleeding heat away from a world that already had almost none to spare. At the time, plenty of Zhang's colleagues found the idea unlikely, and there was no instrument on Earth or in orbit capable of actually testing it. That changed once Webb's mid-infrared instrument became sensitive enough to pull Pluto's faint thermal signal apart from Charon's, something no earlier telescope had managed cleanly. A team led by astronomer Tanguy Bertrand at the Paris Observatory used that capability to measure Pluto's atmosphere directly, and the results, published in the journal Nature Astronomy in June of 2025, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the haze particles suspended inside it, and the effect turned out to be roughly 30 degrees Fahrenheit colder than earlier models had predicted. Researchers are now describing this as a genuinely new type of climate, one that doesn't resemble any other atmosphere we've studied anywhere else in the solar system. Pluto isn't simply cold because it's far from the sun. In a very real sense, it appears to be actively refrigerating itself, and scientists are still working out how far that discovery reaches, including whether similar hazes might be quietly shaping the climate of Neptune's large moon, Triton, or even hinting at what Earth's own atmosphere may have looked like billions of years ago, long before oxygen ever built up in our skies. There's a second discovery tied to that same haze, quieter, but honestly just as strange once you sit with it. Even the faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high in its atmosphere. Those fragments don't simply vanish. They recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles called tholins, which drift downward and settle onto the surface. New Horizons caught early traces of this process back in 2015, and more recent observations have continued to refine exactly how it unfolds. Here's the detail that tends to stop people. Tholins belong to the same broad family of organic molecules that some scientists believe may have once rained down onto early Earth, potentially supplying raw material for the chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years, a slow, continuous snowfall of biological building blocks landing on a surface far too frozen for any of it to ever spark into something alive. To really appreciate how extreme that cold is, look at the numbers. Sunlight reaching Pluto is roughly 1,000 times fainter than sunlight reaching Earth, meaning even high noon there would resemble a heavy Earth twilight. Surface temperatures generally sit somewhere between negative 387 and negative 369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on our planet. At those temperatures, nitrogen, the same gas that makes up most of the air filling your lungs right now, freezes completely solid. The atmosphere around you as you're watching this would, on Pluto, simply become part of the landscape. It's worth explaining why scientists care so much about this particular chemical process beyond it simply being strange. There's a long-running debate about where Earth's first organic building blocks actually came from, whether they formed here on the young planet itself, or whether at least some of that raw material arrived from space. carried by comets, asteroids, or slow chemical processes unfolding in icy environments, much like what we now see on Pluto. Watching a real ongoing version of that chemistry, one that's been running continuously for billions of years on a nearby world, gives researchers something they otherwise couldn't have: an active laboratory for a process that on Earth finished long ago and left behind only indirect evidence. Pluto, in that sense, isn't just a curiosity. It may be one of the closest things we have to a working model of the raw chemical conditions that existed before life ever began, anywhere. The third major finding tends to unsettle people the most, once it's explained properly. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through its thin atmosphere, slip past its weak gravity, and escape outward. Scientists already suspected this was happening, but for a long time nobody knew exactly where all that escaping material actually went. It wasn't simply vanishing, something was catching it. Pluto's largest companion, a battered ice moon called Charon, roughly 750 miles across, orbits in an extraordinarily tight gravitational partnership with Pluto. Most of Charon's surface is fairly unremarkable water ice, ancient and heavily cratered, except at its poles, which are stained a deep, unmistakable reddish-brown, darker than anything else on the moon. For years, researchers suspected a connection between that coloring and material escaping from Pluto, but lacked the tools to confirm it directly. The mechanism turns out to be tied to Charon's extremely long seasons. Because of how Charon is tilted as it orbits, its northern polar region spends multiple decades in complete darkness at a stretch, with no sunlight reaching it at all. That makes the pole an extraordinarily effective cold trap, a place where escaping methane molecules drift in, freeze solid simply because there's no warmth to keep them as gas, and sit there accumulating for years. Once sunlight finally returns to that part of the moon, it doesn't melt the frozen methane away. Instead, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds, locking that dark coloring in permanently. A widely cited 2016 study showed exactly this cycle: methane escaping Pluto's atmosphere, drifting across roughly 12,000 miles of space, getting captured by Charon's gravity, freezing onto its cold polar surface, and then being broken apart by sunlight and cosmic radiation into the same organic compounds that color parts of Pluto itself. Two worlds locked together, quietly trading atmosphere and color for billions of years. Charon had one more surprise waiting. In October of 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm the presence of both carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to disinfect a wound, frozen directly onto Charon's surface. According to the published research, the carbon dioxide most likely originated from underground material exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and rearranging it into something new. That specific combination had never been confirmed on Charon before, adding yet another layer to a moon that keeps turning out to be far more chemically complex than its plain, icy appearance would suggest. Now picture for a moment what it would actually be like to stand on Pluto's surface. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth and no meaningful glare. You could stare straight at it without discomfort. The sky around it would sit in a permanent grayish-blue gloom, thick with haze, never fully day, never fully night. The ground beneath your feet wouldn't behave anything like ice does on Earth. At nearly 400 degrees below zero, water ice stops being slippery and instead behaves closer to solid rock, hard enough to ring almost like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, would offer nothing to breathe, though the extreme cold would freeze exposed skin almost instantly, long before that thin air became the real danger. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving. Pluto and Charon are close enough in size that they don't orbit each other the way Earth orbits its moon. Instead, they orbit a shared point in the empty space between them, locked so tightly that each always shows exactly the same face to the other, a silent standoff running for billions of years. The surface holds its own separate mysteries. In a region named Tartarus Dorsa, New Horizons photographed something no spacecraft had ever documented anywhere else in the solar system: tall, jagged blades of ice, some reaching more than 1,500 feet high, made of frozen methane and arranged in long parallel ridges. Smaller versions of this formation exist here on Earth, in certain high-altitude deserts, where they're called penitentes, and rarely grow taller than an average person. Scientists believe the Earth-based versions form through a slow process of uneven melting and sublimation, carving taller sections, while lower areas erode away faster. On Pluto, that same basic process appears to have played out on a vastly larger scale. using frozen methane instead of water. A 2025 analysis of the original New Horizons data suggests these towering ice blades may wrap around as much as 60% of Pluto's equator, forming an entire ring of jagged frozen terrain circling the dwarf planet. Elsewhere, a massive dark region roughly the size of Alaska stretches across the equator, colored a deep reddish black, where those falling tholin particles have apparently piled up thickest over billions of years on some of the oldest, most exposed terrain on the planet. South of the famous pale, heart-shaped plain, two enormous isolated peaks rise out of the surrounding landscape, and researchers still can't fully explain them. One stands roughly 13,000 feet tall, the other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanoes on Earth. Both have deep depressions at their summits, ringed by fractures, with lumpy, uneven flanks that closely resemble cooled lava flows. Except, of course, there's no molten rock on Pluto. If these features are what they appear to be, they're cryovolcanoes, structures that once erupted not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. Researchers remain divided on whether this came from a handful of massive eruptions or many smaller events spread across a longer stretch of time, but either interpretation points toward the same conclusion. Something at some point in Pluto's relatively recent geological history was warm enough beneath that frozen shell to force liquid material all the way to the surface. That internal warmth leads directly to one of the most debated ideas surrounding Pluto today, the possibility of a hidden ocean buried roughly 100 miles beneath the surface. Kept liquid by the slow radioactive decay of elements inside Pluto's rocky core, the evidence isn't a photograph, it's a pattern. Cracks and ridges across the surface line up in ways that fit what you'd expect from a subsurface layer of liquid water shifting slowly beneath the crust, and that famous heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be concentrated underneath. It's worth explaining why scientists find this so compelling, even without direct proof. Similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons, both of which show far more obvious evidence, including geysers of water vapor erupting directly into space at Enceladus. If a body as small and cold as Pluto turns out to be hiding something similar, it would suggest buried oceans might be a far more common feature of icy worlds throughout the outer solar system than scientists previously assumed, rather than a rare exception limited to a handful of larger, closer, more actively studied moons. If that ocean genuinely exists, it's likely been sealed away for billions of years, cut off from sunlight and radiation, fed only occasionally by hydrocarbons seeping down through cracks in the ice above, sitting under enormous pressure and total isolation. It would represent one of the strangest possible environments in the solar system for the basic conditions life requires, existing without any direct connection to a star at all. Right now, there's no way to confirm any of this directly. There's no funded mission planning to return to Pluto, no lander, no orbiter on the books, largely because the journey alone would take the better part of a decade. And outer solar system exploration has rarely been treated as a funding priority. That's not a matter of scientists losing interest. Missions to the outer solar system are extraordinarily expensive and extraordinarily slow, often requiring a decade or more of travel before a spacecraft even reaches its target, followed by a single brief window to gather data, exactly like what New Horizons experienced. Space agencies have to weigh that against missions closer to home that can return results in a few years rather than a few decades, and distant icy worlds tend to lose that trade-off. For now, Webb remains our only working tool, quietly checking back in every few months whenever Pluto swings back into its field of view, adding another data point each time and more often than not, making the picture stranger than it was before. Here's the detail that tends to stick with people longest after hearing this whole story. Pluto isn't unique simply because of where it sits. It's inside the Kuiper Belt, a vast ring of icy debris beyond Neptune's orbit, home to hundreds of thousands of objects wider than 60 miles, along with an estimated trillion or more comets. A handful of other bodies out there, including Eris and Makemake, come reasonably close to Pluto's size. Beyond the Kuiper Belt entirely lies the theorized Oort cloud, thought to hold another trillion or so icy bodies, stretching outward roughly a quarter of the way toward the nearest star. To put the scale in perspective, the Kuiper Belt alone is estimated to span an area of space hundreds of times larger than the more familiar asteroid belt between Mars and Jupiter, the one most people picture when they think of a field of space rocks. And unlike that inner belt, which has been mapped in fairly close detail thanks to its relative proximity to Earth, the Kuiper Belt remains almost entirely unexplored. Only one spacecraft, New Horizons, has ever ventured deep enough into that region to closely photograph any of its larger residents, and even that mission only managed close flybys of two objects, Pluto, and a much smaller, more distant body nicknamed Arakoth, out of the hundreds of thousands of similarly sized worlds believed to exist out there. If Pluto is genuinely cooling its own sky, slowly bleeding its atmosphere onto a companion moon, and possibly hiding a liquid ocean beneath a shell of solid ice, there's no obvious reason to assume it's the only object doing anything like this. It's simply the one close enough and bright enough for our current instruments to study in real detail. Nearly everything else scattered across that same enormous stretch of space remains almost entirely unobserved. So what does all of this actually add up to? Pluto was never really the dead end of the solar system that a single vote in 2006 made it seem like. It turned out to be the beginning of a whole set of new questions scientists are still learning how to properly ask. Out past the orbit of Neptune, in the cold and the dark, there are trillions of other worlds we've barely glanced at, let alone studied closely. And if one small, frozen, formerly dismissed dwarf planet was hiding this much complexity beneath its surface, it's genuinely worth wondering what all of those other distant worlds might be hiding too. If stories like this one, grounded in real published research rather than exaggerated headlines, are what you want more of, go ahead and subscribe. Drop a like if you learned something new, and let me know in the comments what you'd want covered next. Webb is still pointing back at Pluto every few months, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Thanks for watching, and I'll see you in the next one.